So in this video, we're just going to be doing another example. So we're not learning anything new. So if you felt pretty comfortable with the material, you could really just pause the video and then watch the video to confirm if you did things correctly or not and see where you have questions. If you're feeling a little bit more uncertain, I'm going to help walk you through this, but still asking you to try to do some of the pieces on your own. So let's first read through the example and understand why we're going to be inside this particular set of notes. So we're going to be interested in investigating to see if there's a difference in the percentage of K through 12 students who are eligible for free or reduced lunch. More specifically, we're going to look at this in 3 states in the NKU tri-state area, which includes Kentucky, Indiana, and Ohio. So we took a random sample of students in each state and recorded the state the student was from, as well as if they were eligible for free or reduced lunch or paid lunch. So why is that part important to me? Well, that's important to me because that means I have 2 categorical variables. I have the state that they are from, and then I also have if they are eligible for free or reduced lunch. So state is categorical, free or reduced lunch or paid is also a categorical variable. And then we've summarized the results we found over here so I can see how many students we sampled in each state, as well as the breakdown of the free or reduced or paid lunch in each of those states. So in part A, we're going to calculate and interpret these row percentages. So I'm going to first do Indiana with you, and then have you try the other 2 on your own. So for Indiana, I can see that I had a total of 800 students. So that's going to be my bottom number. My top number is just going to depend upon which column I'm looking at. So I'm going to first do the 390 to help tell me what percent of students in Indiana were eligible for free or reduced lunch. And I'll find that's a little shy of 58%. It's 48.75%. Then I'm just going to move over and do the 410 still out of those 800 students in Indiana and get 0.5125. What's going to happen every time I do row percentages when I'm looking at one row is these numbers better add up to 1 or 100%. Now, since I know I'm going to interpret these, I'm going to go ahead and write this interpretation for Indiana. So we could say of the 800 K through 12 students sampled in Indiana, we know that 48.75%, just that 0.4875, but as a percentage, were free or reduced lunch, while the rest, which was 51.25%, were paid lunch. So I've done Indiana. We're going to do the same thing for Kentucky and also for Ohio. So I suggest pausing the video here and then trying those on your own, because I'm going to come back and we're already going to have the answers. So again, pause it and try it on your own. Alright, so looking at Kentucky, we had 500 total students in Kentucky. 306 of those were eligible for free or reduced lunch, so we're just going to divide those and got 61.2%. Then we took the 194 out of the 500 to get the 38.8% that were paid lunch. So then my interpretation of those 500 K-12 students sampled in Kentucky, 61.2% were free or reduced lunch, and 38.8% were paid lunch. Next is Ohio. So then now looking at Ohio, we had 700 students there. 259 and 441, so just the two numbers we use separately to do our division. So 37% and then 63%. So of our 700 K-12 students sampled in Ohio, 37% were free or reduced lunch and 63% were paid lunch. So that's doing our row percentages. I'm also going to verify these in StatCrunch, and really I'm going to go ahead and show you how we got all of the StatCrunch output that you see here on the next page. So the first thing I'm going to need to do is actually enter my table into StatCrunch. And so I'm going to put my state. I'm just going to go ahead and enter it in the same order that we have. And then I'm going to put my column names. And I don't ever want to enter totals when I do my table here in StatCrunch. So there was 390 Kentucky that were free and 410 that were paid. In Kentucky, there was, I meant to say Indiana for the first one. In Kentucky, there was 306 that were free or reduced and 194 that were paid. In Ohio, there was 259 that were free or reduced, or 441 were paid. Then we're just going to go to Stat, Tables, Contingency, and since I've entered in the table, that is technically what I consider with Summary. I'm going to then Control-click both of the columns that I want to compare where my numbers actually showed up here. My row labels are going to be in this state column. And then to get all this extra information that I see down here, it has the row percent, the expected counts, and the contributions to chi-squared, I'm going to click those things. So I got to Control-click to do multiple ones. So I'm going to click my row percent, my expected count, and my contributions to chi-squared. So then if I hit Compute, I'm going to get all that information that you see on the last page of your notes, where here are our row percentages. So that 48.75%. So there's all of our row percentages that we calculated together. Now here in Part B, we're going to be actually doing the hypothesis test using a 5% significance level. Our first step whenever we do the hypothesis test is going to be our hypotheses. And what I need for my hypotheses is I need to know which one is my response variable and which one is my explanatory variable. So I believe that lunch status is influenced by the state that you live. That's how I'm going to write it, because I mean the outcome variable is really whether or not a student paid free or reduced or paid full price. And I think the state might explain that. So I'm going to go ahead and write then that my null hypothesis is going to be that lunch status, because my response variable always goes first. The null hypothesis will always have the independent in it. And my explanatory variable is just the state. Now my alternative hypothesis is exactly the same, except for the independent is dependent. So there's what my hypotheses are going to look like. Now, looking at these row percentages that we just calculated, what the alternative is really saying, but they're being dependent on the state, is that these percentages are very different from each other. That's what it would mean that lunch status is dependent on the state. If lunch status is independent of the state, that would mean it didn't really matter where you lived, you had about the same chances of being free or reduced lunch. So that's sort of the idea of what the hypotheses are testing. Our second step is that decision rule. So we are going to reject the null hypothesis and instead believe the alternative hypothesis if our p-value is less than our significance level, which was given to us as 5%, so 0.05. For step 3, the first thing that we need are our conditions. So we need a relatively random and unbiased sample. So they took a random sample from each state. So really what they've done here is they've done a stratified sample because they went to each state and then sampled students there. This doesn't seem to have any known bias from what they have given me here. My other condition that I need is that all my expected counts are at least 5. And so if I go look at my output that's in your notes, and also what I just created here in StatCrunch, one of the values that I got was the expected count. That's going to be the third number in each of my cells. So the 382, the 418, so all of these numbers are going to be the ones that I write down for my expected counts. So just writing those numbers down. So we had 382, 418, 238.75, 261.25, 334.25, and 365.75. All of those are at least 5. Our other part of step 3 is to get our test statistic, which is a chi-squared. And there's technically 3 different ways that I can get my chi-squared, depending upon what I'm given. Now, the first way I can get it, if it's already given to me here in StatCrunch, which it is. So it's going to be about 69. Now, if that wasn't there, what would be the next place that I would look? Well, the next place I would look is to see if their contributions to chi-squared are given to me, which they are. So I could just take all of those numbers and add them together. If those aren't given to me, that's when I'm going to have to break down and actually use the formula to calculate them. So depending upon what I got, it could be really easy or it could be a little bit more work. But let's go ahead and do it, kind of showing you all ways. So first, I could just get it from the output. So there's one way. I could have added the chi-squared contributions together. So using those other numbers in the output that we had. And if I do that, that would get me 68.99, so really close. And then again, if they didn't have that, then I would have to go back and do the formula. So kind of showing you the first piece of that one. We would need our observed count and our expected count. So like for example, the 390 and the 382. So if I would take the 390 minus that 382 squared divided by the 382. So it's the observed minus expected squared over the expected. And then I would have to do that for each of my 6 pieces. Because what you'll see when you do this first piece is you're going to get that 0.17 that you see above. So those are kind of like the 3 different ways you could get the test statistic, kind of listed from easiest to hardest there. Alright, the next piece is to get our p-value. Now your p-value is always going to be having to give to you here in StatCrunch. Now the reason why we can't calculate it is because I no longer have a z. In order to use that table that I'm accustomed to using up until now, I would have to have a z, and that's not what this number I just calculated is. So I'm going to have to use StatCrunch to get my p-value. So my p-value is just given to me in my output. It's a very small number. It's so small it's less than 0.0001. Now taking that back to step 2, we have our p-value now. Is that less than 0.05? Well, yes it is. So we are going to reject the null hypothesis and believe the alternative hypothesis. So finally, our step 5. Our step 5 is always going to start with our significance level. So our alpha is equal to 0.05 level. Because we rejected, there is, again, that's related to the rejecting up here, statistically significant evidence to support. And then the last part is always our alternative hypothesis, but in words. Well, the good news here, our alternative hypothesis is already in words. So there is evidence to support that lunch status is dependent on state. Or in a sense, it does seem to matter where you live. There is a difference in the percent that are eligible for free or reduced lunch. So finally, what does that really mean for us? So that is, based upon our answer in part A and B, does it appear that there is a difference among these states? If so, how? Well, so first I'm going to say, since I did reject the null, there is a difference. Alright, there is this relationship. If I would have not rejected, there really would not be any evidence that there is any differences among the states. But since I did reject, I believe there is a difference. Now, looking back at the percentages, that's going to help me figure out, well, how? Well, it seems like you're most likely in Kentucky to be eligible for free or reduced lunch, and you're least likely in Ohio. I can also see from going back and looking at those chi-squared contributions, that's where all those large numbers happened. Indiana's were very small. So, I mean, Kentucky's really seem to stand out. Ohio's really seem to stand out. And so for that reason, those are the ones I'm going to focus on. So Kentucky seems to have the highest free or reduced lunch of our 3 states anyway, while Ohio seems to have the lowest. Now, I do realize these percentages that I just wrote down, that was just for our sample, but those are kind of the numbers I'm referencing for knowing that, well, Kentucky seems to have the highest, while Ohio seems to have the lowest. So hopefully that was another good example to see if you have questions thinking through doing row percentages, the hypothesis test for the chi-square test for independence, using StatCrunch. So again, as usual, please be willing to post questions to the discussion board if needed.